So yesterday I was doing the big Midland base station, and this time we've got, I said we're going to do a Harvard 420M, which is like the Rotel RVC230 in features, and I think a lot of these. That's the Harvard 420M. You've got the same innards as the Rotel 240, you've got the same innards as the York 863 and the Binatone 5-star and the other top end Cybernet 134 sets. And unlike the bottom end Cybernet 134 sets, like the Rotel 220 and the York 861, these have got an extra receive circuit, but not the extra receive circuit that the that the Harrier base station and the Midland base station, which we saw yesterday, has. So you're getting a less cluttered front panel than sets like the Rotel 240, which, if you got that in a mobile situation, is too cluttered. So that's why we like the Rotel 230. We would just as much have liked Harvard 420Ms had we had several of them at the time when we elected to use those as our reference test sets. So, nothing better's come along. We sometimes think it's going to, but it doesn't. So this is coming from a radio ham friend. He's an A licensee like myself, so it's as high as the licensing goes. But he doesn't have oodles of test equipment, so he's passed this on for me to check it over. He didn't tell me the origin. I don't know whether he's owned it from new or whether it's something that's just come along. I think he's somebody where Citizens Band Radio was his introduction to two-way radio, and then he elected to learn more and get into it and become a licensed amateur in the various stages you can do that. Whereas I came into radio before Citizens Band Radio and discovered it 2 years later when it became legal in the UK. I probably said before we had a television and audio shop, and a young lady came in with a Citizens Band Radio, which my late mother took in for repair. I had no idea they were illegal, and did I say I'd know? She'd no idea they were illegal, and so it ended up getting fixed, and I don't know whether I can be done by the government inspectors for fixing that illegal CB radio back in 1979, which belonged to Luscious Lips. So I don't recall what she looks like. So we'll power this up. 13.6 volts. That'll do. We'll switch the radio on. Handily on channel 20. And we'll check the VCO. That one is on channel 40, doesn't it? This. It's funny how we get same chassis, same day running. So we should have 4 volts. We've got 4.1. That'll do me. And we should have 4 volts on the transmit. So key up. We've got 4.3. That should be all right, but we'll check where it is at the other end. So on channel 1, I don't want it to exceed 2.5 volts. Should be around 2.25. We've got 2.2 on. Let's go to a finer scale. We've got 2.25 on receive, and in transmit we've got 2.36. So that's absolutely fine and doesn't need adjustment. So if we needed to adjust that, remember it's adjusted on channel 40 for 4 volts, and receive is the coil there, and transmit is the red trimmer there. And you check it on channel 1, make sure it's somewhere around about 2.25. Okay, so that's one thing we didn't have to do. So let's look at, we'll put picture in picture on and we'll see what transmit power it's doing. And this again, we may as well write down what we're doing, and then it's nice to report back to the customer we've actually done something. So Harvard 420M, Steve. So let's see what power it's doing. I've put the test set to 3 watt mode, and then full scale deflection is 3 watts. It is just under 3 watts. Just change scales. 2.8 watts. And the frequency. Yeah, blow me, I'm doing this on channel 1 instead of changing it back to channel 20. So we'll do the power again. Still 2.8 watts. We'll do the frequency. Slightly low but within spec. It's frequency 27,79085. We'll bring it up again, but I've only put the test set on 10 minutes ago, so that really needs to be on 30 minutes before we do any serious frequency measuring, just for stability. So put it to there and we'll come back to that. So we just need to tune up the transmitters. We're doing those 3 cans. That's on. That's between the wiring harness. They're all right. I think that's the warm green tool. Yeah. And that's the less worn green tool. We're going for maximum. 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 That's 4.5. See whether we can improve on that. Maximum. 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 So it's this one right for 4.4 watts. So we're detuning it to 4.4, and then the green one we need to turn it anti-clockwise. I'll go to the correct display. We need to go anti-clockwise. The manual says 3.8 watts, but we'll be setting it to 4 because that's what they're entitled to and that's what they're getting. And we need to check that it's somewhere around 4 watts throughout the band. So we've gone channel 40, it's 4 watts. We go to channel 1, it's 4 watts. Channel 20 is 4 watts. It's absolutely spot on balance. So that's excellent, because sometimes it's hard to get them exactly balanced, and it can be, you know, 3.8 watts on one channel and 4.2 on another or whatever. So then it's a bit of a compromise, but this one's spot on. Oh good, he will be pleased. Now these low power presets are always dirty, so we may as well deal with that immediately. Switch the power to low. We should have now 0.4 of a watt, so the meter should read there. It reads nothing because it's not working. We'll waggle that control around. was in totally the wrong position anyway. And there we are at 0.4 of a watt. So that's restored his low power function, which I think is a very useful function, and he's sadly missed on sets that aren't 2781. Especially when you're in a convoy and you don't want to blow each other's windows out. Let's look at deviation. So we should be looking at 2.2 to 2.5. So we should have the meter somewhere in the middle. Wallow. Because 2.1 is a bit low. So first of all, we'll check that the first preset, the vertical one, is to its center position, which is ideal for that preset. And then we'll adjust the other one. See how that goes. Wallow. Wallow. That's exactly right. Should have been a little bit quiet on that. So deviation was 2.1 kilohertz, and now 2.2 to 2.5 kilohertz. So that's done. That's done. That has been done, but we need to back check. And then we need to look at the meter, what it says on the front when we key up. So it's banging across, and it should read, of course, 4. Just check with my other glasses that that is 4. Now I've got it at the wrong point. That's 4. So that's that done. There's no capacitors I can see that look distressed. There's no nicotine, which is causing problems. That's transmit done. So we'll move on to receive. So plug in the speaker, no doubt into the wrong socket. I got it right. And let's see where receive is. So switch on the cyanide meter. We'll switch to the cyanide meter. And I would say that's 12 decibels. Oh, it's doing 0.3 of a microvolt, so it's very good. The manufacturer says it should be better than 0.5, and they usually are. I've seen the odd 0.7. Beyond that, it would need repair. So RX is 0.3 microvolt for 12 dB cyanide. So let's just run through that. So we'll start with the detector. Let's go to the oscilloscope. Turn the bench light off and apply an S9 signal, which is 100 microvolts in the UK. And we just need to see. There's the detector coil. Actually, that was quite a bit out. So that's going to help his signal to noise ratio and clarity. So we'll now display somewhere around about 5 dB cyanide and drop the ceramic tool on the ceramic floor. Which luckily didn't break like the other one did yesterday. So So we can start with that coil. Drop the signal a bit more. You know what? We've got some there. We've gained some. He's going to have a cracking set here because it was already excellent. I want a bigger signal for these. Are we done? I've just knocked the signal generator off frequency. There we are, we're back again. So let's see if we've got any improvement on that cyanide reading. So that, I think we could say, is 12. So just, I don't know why we're still showing the oscilloscope screen. So that's 12. It's now doing 0.26. Good. So let's put S9 back on the signal generator. And see what that's saying. It should be showing 9 on the meter. It's just slightly lower than 9. And now it's spot on the 9. And then turn the squelch to full and see when that comes in. So what we want is 100 microvolts S9 equivalent. So when I turn the knob to that position, 100, I want this signal to come in. So we're at 0.3, 1, 3, 10, 30, 100, it's spot on. So it doesn't need adjusting, just like the set yesterday didn't. Well, I'm coming up to sets which haven't been screwdrivered. Preset for the squelch is under that wiring harness just there, but we don't need to touch it, but we do need to check the sensitivity of the squelch. So we're going to turn the signal generator to standby. It's parked at 0.3 of a microvolt, and we will now turn down the squelch and then adjust it for threshold. There we go. Just putting the signal generator back on. See when it comes in. .6 of a microvolt it's coming in at, and leaving it 0.55. So that should be okay. Do you know what? We're done. And that brings us up to the half-hour warm-up period of the test set. We'll just make sure it's still on frequency. .2779124 toggling 5. We're just slightly higher than that. Not that high. So have it there. And there we are. We're done. I'll put the lids back on and we'll pop it on the aerial and as ever not hear anybody. Right, well that's the radio screwed back together and on an aerial. So make sure we're in the correct modes. Have a flick through the channels. Well, Nana Roger. I'll be lucky. We've got one of these of our own, and it's sat in a box waiting for a scrapper to come across because we want the red switch. Somebody's removed the channel 9 switch and done something silly. We've then removed the silliness, but we want a channel 9 switch. It's a red one, and I'm sure there must be somebody out there with a scrapper we can buy. So that's my dilemma. Isn't it lovely living in the middle of nowhere, nobody on? Right, we'll be doing an on-the-air test with that later on, and that's really lovely set. So it came in doing 2.8 watts, it's doing 4 watts, slightly off frequency, we've pulled that up. Deviation slightly there, we've pulled that up. And receive was already good at 0.3 microvolts, we managed to improve it to 0.26 microvolts for 12 decibel Cybernet. Thanks for watching the Harvard 420M Cybernet 134 boarded set from 1981.